What's that? You say you want an example. You got it. Let midnight be t equals 0. At 7 a.m., a train leaves the station 200 miles east of St. Louis and travels west at 50 miles per hour. We can make the equation, x equals velocity times our final time minus the initial time plus the initial position, into our velocity, 50 miles per hour, final time, we don't know, minus 7, the initial time, plus 200 miles is our initial position. Plugging in negative 50 because the velocity is 50 miles per hour west, which is left, so we would use negative 50. Plugging in 7 into t naught because the train leaves at 7 hours after midnight. If we plug in plus 200 into x naught, because we started 200 miles east of the origin, which is St. Louis. We can generate a table by plugging in different times into t and doing the math to get the value for x. Position as a function of time. Remember, functions have input values, which will then generate output values. So if our input is 200 miles, then our time output would be 7 a.m. Or if our time input was 7 a.m., then we would generate a position of 200. Now suppose that you can have car 1 that starts at position x equals 100 meters, going 30 meters per second to the right. Car 2 starts at position 300 meters, going 10 meters per second to the right. When do the cars meet? Where do the cars meet? Let's check it out. We're going to make equations for each car from x equals v times tf minus t naught plus x naught. We can say t naught equals 0 because both cars start at the same time. If all of that is confusing to you, pause it, reduce the speed, rewatch that little portion, rewind. Make sure you're getting all of this. Car A's equation becomes x equals 10t plus 300. Do you see where that comes from? There's our velocity, there's our starting position. Time, we're not sure of when they will meet. Car B, 30 plus 100. That t is going to be the same. When the cars meet, they have the same position, so we can just set x equal to x and solve for time. So both of these ending positions are going to happen at the same exact spot. If you think about this on a ruler, you start from 0 and you start at the other end 100 centimeters. Somewhere along the line, they're going to be in the same position at the same time. Whether it's closer to the 70 centimeters or closer to the 30 centimeters depends on which car is moving faster. The car that's moving faster is going to cover a greater distance in the same amount of time, but the ending position is going to be the same time. Is going to happen at the same exact time. So by setting x equal to x, it becomes the top equation, 10t plus 300, equal to 30t plus 100, which is 200 equals 20t. Solving for t, we get 10 seconds. So these two cars are going to drive towards each other for 10 seconds before they crash. Plug this time into either equation, and you'll see the position will be 400 meters. So once we have solved for the time, how much time has gone by, then we'll take that time and plug it into either one of these two equations to find out what that position was. You may have never done anything like that. If you've never done anything like that, you now see the answer. Go back, try it for yourself. Pause this video, circle back, start on a new piece of paper, and try this problem for yourself. This whole process of figuring out what is the same, okay, x's are the same, so let's set those equal to each other. This is going to pop up repeatedly for the entire year. So it's a useful skill for you to get used to. In math class, when you do cover it, this won't be so foreign to you, and you'll be one of the ones in the class that everybody's looking to for help. Here's what it looks like. Boom. They meet at 10 seconds at position x equals 400 meters. Now, let's say we have car 1 that starts at x equals 100, going 30 meters per second to the left. Car 2 starts at position x equals 300 meters, going 10 meters per second to the right. Again, when do they meet? Where do they meet? The starting position is different. The ending position is still the same. Make equations for each using our position as a function of time equation. We can say that t naught equals 0 because both cars start at the same time. Car A's equation, x equals negative 10 times t plus 30, and car B's equation, x equals 30t plus 100. We're setting these two equal to each other, solving for time. Then, once we get our time to be 5 seconds, we'll take that 5 seconds and we'll plug it into, I would do car B's equation just because it's all positive, and that's one less thing I've got to deal with. So 5 times 30 is 150, plus 100 is 250. And here's what it looks like. They're meeting at x equals 250 after 5 seconds. Boom. Advantages and disadvantages. We know where the object is, what the object is doing at any time we want. Sorry about that. Disadvantage. If the motion changes, the object's speed changes in the middle of the motion. Then the equation stops working and we have to switch to a new equation with a new velocity, a new initial position, and a new initial time. What other ways can we represent? Is there a representation of motion that has no gaps and also allows you to easily show changes in motion? Yes. It's called a graph of motion.